about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I am Leonard Facchinetti, and let's write some code together, shall we? What we have on the menu today continues to be the waveform display. In case you're new here, we are doing this component. It's a waveform display for real-time audio effect processors in REAPER. We are mainly focusing on the visualization aspects of audio effects. I want to show what the audio effect is doing to the waveform. And this is what it looks like right now because it is broken. So our first task today is to fix this. Find whatever is broken, and we will review the whole implementation, trying to find that bug. And then there are some other things. If we manage to get this to work, there are some other things that I want to investigate. Let's start by reviewing the implementation. We have a data structure where we keep these things called slices. So you can think of a waveform as a bunch of slices. Each slice is 1 pixel on the x-axis. And then as you plot all the slices together, it makes up for the whole waveform. So we have this slices data structure that is a circular buffer. So on the audio thread, we are computing the slices by looking at the maximum and minimum sample in a range in certain amount of samples. So we take a block of samples that is this size, and then we take the maximum and the minimum sample in that block, and we store that in these 2 circular buffers, one for the maximum, one for the minimum. And when I say circular buffer, it just means that it's a data, it's like a list, and when I traverse the list from left to right, and when I get to the end, I wrap back to the left. So I can think of this as a buffer that is circular because the last item and the first item are connected. Then in order to compute this, as the samples are coming in order to compute the maximum and the minimum for one slice, for the slice that I am actively working on, as audio comes in, as samples come in, I need to know how many samples there are already on the slice. I need to know how many samples I want to have in one slice. So the case here is that there will be like 48,000 times a second, there will be a sample coming in, but we are not able to display 48,000 samples here because we don't have 48,000 pixels across the screen. So what we do is we reduce the samples into the slice. So we take, like, let's say 1,000 samples makes up 1 pixel on the screen or one slice. So this number would be 1,000 in that example. Naturally, this number is actually computed based on the duration. So how much time I want the waveform display to actually show. I guess in our example, it's 5 seconds. And it's also based on the width of the component. So if it's going to take like 700 pixels on the screen, and that's supposed to accumulate 5 seconds worth of samples, you can make out how many samples there will be on each slice, on each pixel across the screen. Then I also have to temporarily accumulate the minimum and the maximum of that slice over here because I will want to eventually put it there in the circular buffer, but as I'm working this up, I have to keep all these 4 pieces of temporary data. Then that's all on the audio thread. That's all the processing that is happening as samples are coming in. And the purpose of this circular buffer is to accumulate the samples and store them for the user interface thread to read. So the user interface thread is going to look into these two circular buffers, and it's always going to be lagging behind. So the circular buffers will be writing more slices as audio comes in, and the user interface thread will be behind. So it will be catching up to the slices that have been written. And that's what this read index is all about. The read index is where the user interface thread is in any particular time inside this circular buffer, where it's pointing at in the circular buffer. So audio comes in, and this finger is the audio thread. It goes and writes to the circular buffer. This is the pen, is the read index. It is the user interface pointer that tries to catch up. And the write index I don't have to have explicitly here because the circular buffer data structure takes care of managing the write index, but the special read index that I have here that catches up to the write index is not managed by the circular buffer data structure, so I have it explicitly. Then, what do I do in the user interface thread once I have read the slices from the circular buffers? Well, I draw the waveform into this temporary image. It's an image that is off canvas. You don't actually see that image. So I draw the waveform display there. Then finally, what I will do is draw this off-screen image into the screen, into the frame buffer that we actually get to see on the audio effect here on the REAPER user interface. So that's, on a nutshell, how the thing is going to work. Oh, and I should also mention that there is this write index. The image that we draw to, this temporary off-screen image, it sort of amounts to a circular buffer in the way that we are using it. So this write index is the write index into the image. So the user interface thread is going to read from the circular buffers, and it will draw into the temporary image, and it will go from left to right in the temporary image. When it gets to the end, it's going to wrap back. And this is the write index that represents the position we are drawing to in the temporary image, off-screen image. So that's in a nutshell how the thing is supposed to work. Now let's review the code that is actually implementing this. To begin with, there are all these pieces of the data structure. We just went over that and it seems to be okay. The indices are also correct. They're just incrementing. And this is the function that creates an instance of the waveform data structure. It needs to receive the width and the height of the temporary off-screen image. So these two fields here, that's what it receives as argument. And this width and height will not change. You may, if you want, repaint this temporary image in different locations on the user interface. If maybe you want to move it around as you resize, for instance, that's totally doable. But the off-screen image that we draw to, this circular buffer kind of, has a fixed width and height, and it does not change. And we also receive here a duration, so that when you're creating the waveform, you need to tell me how long you want to show. I guess in our example, 5 seconds. So you would pass 5 seconds worth of samples. So 5 seconds times 48,000, for instance, in my case, because my sample rate is 48,000. So that's what is up with all of this. Now let's go over the body of the function and see how it's working. So first of all, it needs to allocate some memory for all the 11 fields, 0 to 10. Then on each one of these fields, it needs to initialize them somehow. And now I'm highlighting stuff and checking that I don't have any typos. So when I select something, Visual Studio Code is going to highlight other occurrences of the same text. So I can just quickly check that the text matches what's below. and that I don't have any weird typos, because if I had them, it could be the source of the bug. But apparently it's not. So let's go over what we do to initialize all these fields. The circular buffers are kind of easy. I just create circular buffers of a given size, 300. And this 300 is how many slices we will store in the audio thread for the user interface thread to pick up. As long as we have the user interface thread running every so often and collecting the slices, will be okay. And the leeway that we have is 300 slices, which is a lot. Imagine if this waveform display shifted to the left by 300 pixels, it would be a major gap. So 300 is a very safe number there. Then we initialize this notion of one slice. As samples come in, we are making up this one slice. How many samples are there in the slice to begin with? 0. What is the number of samples that we expect to have in one slice? Well, that is the duration, which is given in samples. And by the way, we need to double check that we are passing this in samples. We are. So this is the duration given in samples divided by the width. So I will have something that is in terms of samples divided by something that is in terms of pixels. So I'll have something in terms of samples per pixel, which is exactly what I need. How many samples we will collect for each slice, which is given in pixels. Then, to initialize the maximum and the minimum, I do a clever little bit of initialization here. I set the maximum to -infinity and the minimum to infinity, so that later I will be able to take the minimum of whatever is already in there, or the maximum of whatever is in there, and the sample that comes in. So the maximum of -infinity and any sample that comes in between -1 and 1 will be that sample between -1 and 1. And moving forward, I will just continue to take the maximum between whatever is there and the sample that comes in. The read index starts at 0 because the circular buffer write index also starts at 0. Then the image, this temporary image that we draw to begin with, is undefined, because I will only have all the facilities necessary to allocate this image once I am in the in the GFX block. And initialization doesn't happen in the GFX block, it happens in the init block. This function is supposed to be called on the init block, but this function will not have access to some of the GFX functions we need to actually allocate the image, so it starts as undefined. But the width and the height of the image we have access to right here. They were given by the user, so I just store them. And then finally, this circular buffer, so to speak, this temporary image, has a write index starting at 0, much like every other write index in the circular buffer and even the read index over here, they all start at 0. And then I return the address location for the data structure I have just allocated. So far, so good. It seems correct. Next is this function that is called in the audio thread. So let's go over here the use of this data structure, the use of the waveform display. This is the library that we are working on, and this is an effect that uses the library to demonstrate how it works. So the initialization here is actually doing multiple waveforms, one per channel. We are actually just plotting one. We're collecting many. And this is just a chunk of memory. The size of it is given by the number of channels. Loop over the number of channels, create a data structure with a width and height of 768 and the duration of 5,000 milliseconds converted to samples. The serialized block is just a preamble that needs to exist for various reasons for this variable to be available here. Then the block is doing some other auxiliary work. specifically to determine if the GFX block is running. So over here we detect, is the GFX block running? In other words, is the plugin visible? Or are we hidden just like that? Okay, so that's what this is about. And then if the GFX block is running, in other words, if the user interface is showing, then we loop over all the channels and we push the sample for that given channel on the waveforms data structure using this push method or function. And that's what we are about to look at right now. The whole implementation fits on one screen, which is great. So it receives as arguments the waveform data structure and the sample that you want to push. And then, oh, actually this is something interesting. Over here we only had one local variable, so that was easy to check, but over here we have plenty of local variables, and on the next function we will have even more. So one thing that we can quickly check is if we have any local variables that are leaking. So this is the view that shows all the variables, and oh, interesting. Something interesting is happening. First of all, yes, there is a variable that is leaking. It was supposed to be a local variable, but it wasn't declared as such. So there are, I guess, two of them. Version, waveforms, and channel are variables in my program, but these are variables that are leaking. So that's something that I need to look into and fix. I need to add them to the local block. But what's interesting is that I am running the latest version of REAPER, which is REAPER 6.56. At least it was the latest this morning. You know how the REAPER people update REAPER very often, but it was the latest this morning. And it seems like it changed the order of the variables here, which is unfortunate. Previously, it was sorting the underscore last, which meant that all my variables with underscores are my variables in my library. They were all below, and that was good. Now it no longer seems to be the case. And that's bad, because then if you're using the library, this view will be cluttered with a bunch of things you don't necessarily want to look at. And moreover, these things will be the first things you see. Well, but let's fix this at least. These two variables that we know are leaking into the global context. One is the height midpoint. And yeah, it seems like I am not declaring this, and it should probably be right after image. And the second one is the read index. Oh. Yeah, I am not reading from the read index here. That is for sure a bug. Because this is the variable that has the read index, not that bare read index variable. It needs the namespace for it to work. So yeah, that's one thing that I always like to do. I like to check if I am leaking variables into the global context, because sometimes it does reveal bugs, and it seems to be the case today. So now the waveform display is working. That was the bug. It was a simple variable that was misnamed. Let's double check the context, just the global context, to see if we are leaking any variables. Okay, we are not, because the waveforms is this list, then version is this variable, and then channel is this loop variable that occurs here and there. So we are good. We fixed the bug. Let's commit the fix. But even then, I do want to go over the code that is implementing the whole logic I just described, even though now I am sure that it is working, but I do want to go over it to see if there is anything that we are missing and that needs to be done. So let's go over the code that runs when the sample block is running, and that is supposed to accumulate a sample into the waveforms data structure. To begin with, I just deconstruct or destruct the data structure to get its components. So that's not the most interesting part of this. And then we will end by updating some parts of the data structure that change, and we return the sample that was given as the return of the function call itself as a convenience. Because maybe you want to push into the waveform and do something with the sample on the way out. We are not doing anything. We are discarding the return of this function, but we could be doing something. So how does it work? How do we compute one slice? Well, we just take the existing maximum. Remember, to begin with, that is minus infinity. We take the maximum between what's there and the sample that came in. Similarly for the minimum. Then I do this circular counter trick, which is essentially just saying add 1 to the number of samples in the current slice, but limit that number to the maximum. And there is one small tricky business here, that the maximum is the result of this division, which may not be an integer. So suppose that there are 7.5 samples per slice. Well, you cannot divide a sample in half that way. So the way that this is going to work is it's going to count up to 7.5. Then it's going to count up to 8, and then wrap back to half, and then count up to 7.5. So in effect, one slice is going to have 7 samples, the next is going to have 8 samples, then 7, then 8, and slices alternate like this in the number of samples that they contain, such that on average each slice has 7.5 samples. Then this next line is to say, have I just wrapped back? Have I just accumulated one full slice? Am I done? Am I ready to move on? Because that doesn't happen often, right? There will be maybe 7.5 or maybe 500 samples before I actually am able to produce a slice. Otherwise, I would just have to keep accumulating stuff here on the minimum and maximum. But okay, suppose that it has wrapped back, so we have accumulated enough samples to make one slice. Well, then in that case, I just push the slice maximum and minimum into the circular buffer and reset with code that looks exactly like this. And then the slice samples has changed because of the use of the circular buffer here, as well as the slice maximum and minimum, which may have been updated or maybe even updated and reset. So we store all of these guys for next time. Then let's look at the function that draws on the screen. Over here we can see how it's used. We pass as arguments. So first of all, there is some preamble that is necessary for other things in the library. Then this other preamble, and then I guess I will move this up so it is more apparent what's happening here, so that the rest of the code is just a comment. And then how do you use the waveform display to actually draw something? You call the draw function, you pass along the waveform and a bunch of other arguments. Let's look at them side by side. So the X and Y position you want to draw to, and the width and the height of the drawing. So remember, there is this temporary off-screen image, and then we want to plot that image onto the... Hang on, something weird is showing up here. Oh, interesting. Something happened here in OBS, but it's fine. So we have the X and Y positions. What is the width and the height, not of the temporary off-screen image we draw to, but the width and the height of the place you're plotting to. And if you're clever about the use of this, you can do things like zooming into the waveform, making it bigger and smaller to maybe respond to changes in the size of the effect itself. So maybe you can resize the waveform based on the size of the window. It's not what we are doing, but we could do it. And then whether you want to square root the samples, which makes the waveform thicker. Then whether you want to scroll the waveform, which currently we are. Whether you want to erase on wrap, and that's when you are not scrolling, and the waveform is going to draw from left to right and then wrap back. If you want the thing to erase when it wraps back. So that's similar to what real limit does. When it's drawing its waveform, when it gets to the end and it wraps back, it just erases the whole screen. And you can see that in this case, it's not scrolling. And if you want, it can scroll like this, just like our waveform display can scroll like that. Great. Then there is the fill color and alpha. That's for filling in the shape of the waveform. Then we have the stroke color and alpha, and that's for the stroke that we currently don't have. It's commented out, so we have to address that. And then we have a cursor, which only really applies when you're not scrolling the waveform, but it's a cursor that could be showing you this part of the movement here. It could be showing you this part where I have my cursor on. And we have some settings here, but they are ignored, essentially. Then we have a bunch of local variables that we have just verified. They do work, so I don't have to worry about that. Oh, and we also have this frames per second visualization here. It's just to help us debug stuff, so pay no mind to that. We have some changes. I will commit them. And then let's see how this function works. It starts by collecting a bunch of parts of the data structure. And again, I will sort of select names here just to make sure that I don't have any typos. All right, so the first thing we are going to do is to check that the image is defined. Because remember, I said that we couldn't define the image when we allocate the data structure. We have to allocate the image when we have access to the GFX functions, specifically this one. So if the image is undefined, I will allocate a new image and then I will set its dimensions. Then I calculate the midpoint, which is just a helper for stuff that is going to happen below. And then I say that my destination, the place where I'm drawing to, is this temporary off-screen image. And then I check, do I need to reset? In other words, have I just gone to another plugin and come back? In that case, I want to reset what's there. So I will do this bit here. Another case in which I want to do this is if the samples are not running, if the sample block is not running. That happens when you bypass the plugin. Yeah, I don't want to show the waveform in that case. I wonder what real limit does in that case. It just pauses. But if I resume, it's going to pretend that these 2 points in time where I have the cursor have occurred right next to one another. And in reality, they didn't. So that's why I don't like it. I don't like it that way. And I prefer to reset the screen instead. I think it makes more sense for the waveform to just disappear at that point. Then how do I reset stuff? I say that the right index is back on the left. And I use this mul add rect on... What are the arguments for this? I forget. Okay, it's the X and Y position, the image width and height, and then multiply red, green, blue, and alpha by 0. In other words, just erase everything that is in there in that image. So that's how I reset the image. And I have to do it this way because I want the waveform display to be transparent, so it can occur on top of other things like a grid showing time or some other kind of user interface that you want to have, like a background image or whatever. Then this is the meat of the drawing. I'm going to draw to the off-screen canvas. This is catching up the read index to the write index. And the write index came from the circular buffer. The read index is our own piece of data that we are maintaining. Then we collect the slices, the maximum and the minimum, from the circular buffer. We read that. If we want to square root, that's the time when we square root. We do that by square rooting the absolute value and then multiplying by the sign. Then we update the read index because we are done reading. Then we set the coordinates for the slice. The X position is just going to be the write index. And we will have to update the write index here below. We'll get to that. The top of the slice is the midpoint minus the maximum times the midpoint. Okay, so that means I am going to go like this. I go to the midpoint. Suppose that, yeah, I guess the size of the drawing canvas is somewhat like this. So this is going to be the midpoint minus the maximum. So minus means go up, because the coordinate system has y 0 here and positive values going down. So I want to go up, I subtract. And the maximum needs to be a number between 0 and, or between -1 and 1, times the midpoint. So if it is 1, it's going to go back up, right touching there. And then the bottom, pretty much the same thing, except it's using the minimum. So this is the point where we convert from maximum, minimum to top and bottom. Then the y coordinate is just the top, but the height is the bottom minus the top. So the bottom minus the top is going to be the height of my thing. Then I do this, which erases what was there, not on the whole image like this, but just on one slice. I just take the x coordinate, the y coordinate is 0, the width is 1, the height is the height of the image, and then I multiply by a bunch of zeros. I set up the color of the fill, I set up the alpha of the fill, and I draw a rectangle, which really is a line. It's not really a rectangle because the width is 1. But the coordinates are the coordinates I just computed. Width is 1, height is what I just computed. Then to update the write index, it's a circular counter, similar to what we did with the read index when we were writing into the circular buffer. So similar to this line, except that this time, of course, I am wrapping back on the image width. And again, I check if this has just wrapped around. And if I am not scrolling and I want to erase on wrap, then I erase the whole image exactly the same way I did here. So this loop is over and it has updated temporary off-screen image. We are ready to do the actual drawing. So we go to the main image, the main destination, which is the plugin user interface itself. We set this to be completely opaque because if we wanted the waveform to be to have any transparency, we would have set it here. So it's fair to make this completely opaque. And then I check if I am scrolling or not, because I will have to draw the temporary off-screen image into the main buffer differently, depending on whether I'm scrolling or not. If I'm not scrolling, it's simple. I just split the temporary image on without any scaling, without any rotation, on position 0, 0 of the temporary image. Okay, so X, Y, 0, 0 image width and height of the temporary image on positions X and Y, and this is wrong. This should be just width and height given to me by the user with these arguments. Yeah, I think that this is correct. In fact, let's go back to the waveform display and change the scrolling from true to false. So now it's going to not scroll, and then we'll be able to see this function being called, and it should be correct. So let's remove the waveform display and re-add. And this time you can see the cursor coming across, and you can see the drawing happening just fine. This split seems to be working great. Right, so next, let's play around with this, because we are actually plotting the image to the top left with the same dimensions. So these coordinates can be wrong, and it would be hard to tell, because the coordinates of the off-screen image and the coordinates on the actual user interface happen to be the same. That's no good. So let's commit what we have and play around with this for a little. Just for a little while. So I will have a slider for the X coordinate. And I will call it X. I'll have a slider for the Y coordinate. I'll call it Y. And I will have a slider for the width. Let's look at our widths. To pick up a number that we like. So let's say that the minimum is 96. There you go. The maximum is 768, because that's the maximum on the temporary image, like this. And the step is 1, and this is our width. I'll keep the height dimensions exactly the same. And then this whole scaling, we don't need to do on the waveform display. We can have that logic on whoever is calling the waveform display. Yep, perfect. So this scale doesn't have to exist. And with that, I can actually get rid of zoom, which is one of our to-dos. Maybe not. Maybe not. Yeah, because you may want to be able to zoom into a part of the waveform, and then if I receive these things as arguments, if I receive these coordinates of the temporary image as arguments, then you could implement zoom yourself if you wanted. So we may look into that. But anyway, we have these guys, then we can pass them over here. So this will be X and Y, and this will be width and height. Okay, so now I should be able to just move the component as a whole across. And it seems like that is working. I should also be able to move the component up and down. And it also seems to be working. And I should be able to resize. And that is not working right. Yeah, so it seems like there is a bug when you are doing the width because the bar doesn't update accordingly. Let's start taking notes here. Things that we need to fix. So we need to reintroduce the contours or the stroke. We need to fix the position of the, what do I call it? The cursor. So we need to fix the position of the cursor based on the width of the glitch. And let's take this opportunity to actually check what this code is actually doing. So it's splitting the temporary image. Remember that at this point we are drawing into the main canvas onto the user interface itself. So we're bleeding into the main frame buffer. And the thing that we're bleeding is the temporary image. No scaling, no rotation. The coordinates are 0, 0 image width, image height, and that's the thing that I am considering maybe receiving as an argument. And this is where I am drawing to. So I'm drawing to x, y, width, and height. Okay, nothing too surprising. Then we still have to review this much, and we'll get back to that in a moment. But let's look at this code, because this code is drawing the cursor, and the bug that we need to fix is right here. And before we get to that, let's just look at this. The read index, the image, and the write index are the things that may change. That seems to add up. Yeah, the image may change because it may have been allocated. Sorry, not here. The image may change because it may have been allocated. The write index may have been updated there. And the read index is not something that exists. Hang on, it is something that exists. Oh, and it's being updated as well. Okay. So let's look at the code that is drawing the cursor. So if I am not scrolling, because I don't want to draw the cursor if I'm scrolling. If I'm not scrolling and the cursor width is greater than 0, then I switch to the right color. And I draw a rectangle at, okay, this is the issue, this is the bug. But the y coordinate is correct. The cursor width and the height are correct. This is the bug. This is the part we need to fix. So we want to take the x coordinate plus the right index times the width divided by the image width. I'm not sure if I have this right, but let's reason about this for a moment. Suppose that my right index is 100. Suppose that my image width is 700. 768. Is that what I have? Is that what I'm using? Yeah, 768. That means that I am at 100 divided by 768 into the image. And then I want to multiply by that by the width. So yeah, I think that I have this right. I guess I would just swap these two arguments, these operands around, just make things relatively easier to read. But yeah, the right index divided by the width times the width of the image I'm drawing to. So I think that with this fix, the cursor will behave correctly even as I resize. Let's try. Okay, so the trick is that I want to do this, and yes, my cursor does work. It works correctly. Great. Great. Fixed one bug. Where is the comment for that? Fixed position of the cursor based on the width of the bleach. That's what we just did. Then we need to review this code. This is so tricky. I find that super weird. So the way that this works is the actual off-screen image that we are drawing to actually looks something like this. To make it look like it's a scrolling waveform, what I do is I bleed the thing to the left of the cursor, right here on the right, and I bleed the thing on the right of the cursor to the left of that. What this means is that the two bleeds will be touching right here on the boundary, and it will look like the waveform is scrolling. Let's change this to be a scrolling waveform, or maybe let's have sliders for that. Right, let's have sliders for that. So over here we have x, y, width, and height. Next we have square root. Am I right? Yep, we have, oh, hang on, no. Yep, we have square root. So I will have a slider 5 that I will call square root. It will be by default false. And this one will be it will be a drop-down menu. And I learned today that if you just put a bunch of zeros here, that works. So that's what I'm doing. I find it better than having to count. In this case, it's just 2 options, but if I have more options, it's annoying to have to count them. So if you just put a bunch of zeros here, Reaper is going to do the right thing. Next, we have scrolling. So it's going to be similar to that. And I call it scroll. Oh, I guess. Okay, I'm gonna use a trick here. Or maybe not. I would just say scroll, false, and true, and by default it will not be scrolling. Okay, next, erase on wrap. This is slider 6, and this will be slider 7, and erase on wrap is actually an interesting parameter, because it should only exist when the scroll is false. So I'll have here a slider block that will use slider show. Yep. So I will use slider show with this slider, and I will tell it that it should only be showing if scroll is not true. Then for slider 8, we'll have, well, these are just colors. Yeah, let's not have sliders for colors. Now let's revisit this. Where we have this, we put square root. Where we have dash, we put scroll, and this becomes erase on wrap. Okay, so moving the X, moving the Y, moving both of them, moving the width, moving the height, moving both of them. Square root through makes the waveform thicker. And interestingly, when I am resetting this, it's scrolling back to the left. That is surprising to me. It seems like the change of the slider is resetting a bunch of variables. That's odd. I find that weird. But anyway, the square root is doing its thing. It's making the waveform thicker. Then if I want to scroll, then it goes like this. And you can see now that I'm scrolling, I don't have that option to erase on wrap anymore. See, it goes away. Right, so let's do the test of the erase on wrap. I will not do anything and I'll just speak for a while and then it's going to wrap back. And it's not going to erase what's on the right. But if I turn this to true, then it will erase what's on the right when it wraps back. And it erased everything. Then when I have scrolled through, it should be scrolling just fine. And then we can change the X position. That's broken. We can change the Y position. That's working. We can change the width. That's broken. And we can change the height. That seems to be working. So now let's review the coordinates here. And try to get that to work. Well, we are going to bleed twice. Once the thing on the left of the cursor, twice the thing on the right of the cursor. So we're going to bleed the image twice. We don't need any scaling or rotation in either case, but we do need to think about the coordinates. The coordinates first on the source, our temporary image, and then the coordinates on the user interface. So first, the bleeding of the thing to the left of the cursor right next to the right-hand side of the image. That's what's happening here. So the coordinates on the temporary image are, I want the thing on the left of the cursor. So I want to start at 0, 0 on the temporary image. That's correct. And I want the width to be our right index and the height to be the height of the image. So that much is correct. Then, where do I want to draw this on? Well, this is wrong. It should be taking in account this bit. Yeah, so I have here the x coordinate of the point where I want to draw the component plus the width of the component. That gives me the right-hand side of the component. Then I want to go to the left by an amount that is proportional to the right index, but I want that to be proportional to the right index, but I want it to be in terms of the width of the component. So that's why I have to take the right index and do this bit to rescale it. And then I want to bleed to the Y component, that is right, and the width of this bleed is incorrect as well. The width of this bleed is this. And the height of the bleed is correct. So it seems like we are doing this over and over. We might as well have a local variable for this. It needs to be declared somewhere around here because the right index will have been updated. So I will just take this out of there and I am going to give it a name. I guess this is this is some sort of width, but I don't know exactly of what. Just don't know what to call this. I'll call it something width for now. And this variable is going to be global and it's going to leak and all sorts of trouble will arise. But anyway, just need a name for that right now. Okay, so x plus width gets me the right hand side of the component minus this something width that is taking me to the right location where I want to bleed to. And the width of the bleach is this, and the height of the bleach is that. So that is correct. Then for the second bleach, I want to take the right-hand side of the cursor on the temporary image, and I want it to I want to bleed it to the left-hand side of the component I'm drawing. So I will bleed the image, no scaling, no rotation. Then this x coordinate needs to be the right index. So we pick up right where we left off. The y coordinate is 0. Then the width of this bleach is the width of the image minus the right index. That seems to add up. The height of the image, that's okay. Then we want to bleed to x and y. That seems to be correct. The width of the bleach is incorrect. It should be minus the something width. Oh, and this should be the width of the image. The bleed of the frame buffer we are drawing to, not the width of the image. Or not even the width of the frame buffer, it's more like the width of the component we are drawing. That's the right way of saying this. So if we take a step back, these coordinates must be in relation to the image. And similarly, these coordinates must be in relation to the temporary image. That's correct. And these coordinates must not be in relation to the image, they must be in relation to the component. And that also is correct. And then there is just this something width that we have to name. Well, this is not the width of the image. And it's also not the width of the component. It is more like the width I guess I'm going to call this the image, or maybe the right index width. It's not a perfect name, but I guess it captures a little better what I'm going for here. Or maybe, oh, see how we are using this here? This could be the cursor x coordinate. Then this plays very nice with this part. And it also makes sense elsewhere. Great. So right after we do probably at the end, actually, image index, right index is the last one, so we'll do the cursor x coordinate. Yeah, perfect. I think that this makes sense and it stands a chance of working. Let's re-add the effect into the track. Okay, so we have to scroll, and then we want to play around with the X position, and this time it seems to be working. And we want to play, I guess, with the cursor as well, just to double check, but the cursor seems to be working fine. It goes to the right as it should. Then we are going to erase, to scroll, and we can play around with the X coordinate. It seems to be working fine. The Y coordinate, that was already working, I think. The width should make this shorter. And the height, that was already working, I think. It just continues to work. If I take the square root, it makes it bigger, which is nicer, I guess. Yeah, okay, I'm very happy with this. This worked great. And do we have a to-do for this? Nope. Let's just review what we did. So we introduced these sliders for, well, just to help things, to help test things. And then we introduced this cursor X, and we put this, finally we nailed these coordinates. I was kind of putting the temporary image, and I was kind of avoiding having these sliders here and these sliders here because I knew that these coordinates were wrong. But now we revisited this and I think we fixed it. I think that these coordinates are right. Great. So what do we have next? We have to reintroduce the stroke, and is there something else that is more fun to do right now? I guess I will put this next to that because it has to do with the stroke. This can be a bit fun. This is no fun. This is no fun. This is kind of fun as well. So I guess I will do it in this order. Okay, let's investigate the relationship between the buffer sizes and the smoothness of the waveform. What's this about? Well, yesterday I was having a meeting of the C++ Digital Signal Processing Study Group, and we were talking about how Siwitz wanted to sync MIDI with time. So he wanted to be able to record MIDI as you're playing, and naturally you want that to be in sync with the timeline. And I mentioned how I am doing some kind of time management, some kind of time tracking by counting samples. That's how the waveform display works. On the sample block, we push, and then on the GFX block, we read. And this is effectively counting how many samples have been processed. And that's our notion of time. This is going to determine how much of the waveform is going to slide along and whatnot. So effectively, we are looking at the sample block as a way of tracking time in the user interface thread. And then Siwitz brought up an interesting issue, which is if you do it like that, then your notion of time depends on the sample, on the buffer size, because samples are not really processed one at a time. They are processed in blocks, the buffer. And right now my buffer size is 256 samples, but I can change this buffer size. And it will have an effect on the concurrency of things. So the question then becomes, do we need to take this in account? Do we have to worry about this at all? I really hope not, but we'll see. So right now we are running at 256, which is a relatively low number. It's not a lot of latency, which means that this is probably one of the ideal scenarios here. Because, why? Well, yeah, having a lower sample rate gets a lower buffer size gets us closer to the ideal of processing one sample at a time. So this is probably the best looking thing we can have. Now let's change the block size. And I guess I will make this component as big as it can be, because hopefully that will show up the artifacts a little better. Let's re-add this from scratch, and I will want it to scroll, because usually the scrolling shows the glitchiness and the scrolling smoothness better. So let's go from this to that. And I will put this on the second screen. So it's 2048 now, and I applied. Oh, and would you look at that? The block size does affect this. Now, I wonder if I just re-add this to the track, if that works. Nope, does not. Oh, crud. Yeah, right. So with a bigger block size, I will have fewer opportunities on the audio thread, fewer opportunities on the user interface thread to read those samples. And that is not making things happy. Okay, let's try something else. Let's try 1024. And this time, it is working and glitching just a bit. Sometimes, if a frame or two is dropped, if I move this around, then a frame will be dropped and then it erases itself. Crud. Well, maybe we can fix this simply by increasing this number. 1000 is still not a lot, and it gives us more time. So let's try it this time. Well, we already saw one glitch, but let's give this a try. It's scrolling fine now. It glitched. Oh, fuck. And with 2048, there is not a chance. But if we make this number kind of too big to be reasonable, but still, we do have the memory. Does that help? It does not help. So maybe the problem has to do with our detection of whether we have reset. Yeah, I think that is the issue then. Let's return this to 300, because we do have a lot of code that is checking whether we have reset, checking whether we are running on the GFX block from the sample block's perspective and vice versa. What if we just don't check any of that? So I can just remove these lines. Now I'll be pushing samples unconditionally. And similarly, on here, I can say false, and maybe I can just remove these lines and I will never reset. And now it seems to be working again. And I am at 2048. That's my block size. Okay, so the bug is not on the waveform display. So in one sense, that's good news. The bug is detecting whether something is running or not. And over here, I would say that the smoothness has been affected, I think. Maybe Seewitz is right. Okay, I am going to, right now it's running at 2048, and now I applied and it's running now at 256. So indeed, the buffer size affects the smoothness. The way to fix this, yeah, we learned that one way of fixing this is to look at the clock instead. So maybe looking at the clock will be the answer. We are going back and forth with this notion of using samples as a counter or as a time passing device. We're going back and forth, but yeah. And we do need to fix the notion of whether something is running. So let's go back here. I don't think that this one is to blame. I think that this guy is working. So I will re-add that and put the effects back on and see, it's working. Oh, but the block size is 256. Let's go to 2048. And that, yeah, it's not as smooth, but it's still working. Okay, so the issue really seems to be over here where we are doing this bit. And naturally the issue is not with the code that is here, but with the notion of how we define GFX reset. So let's see. It works by looking at whether the GFX was not running. And that in turn depends on this. So maybe this is too small. Maybe I can just increase this number and see if that works. Okay, that number is not big enough. How about 100? And that number is not big enough. How about 1,000? Okay, that number is not big enough. How about 10,000? Okay, that number is not big enough, so maybe that number is not the solution. Well, maybe the number was too big. Maybe the number needs to be 1. Well, if it's 1, it's always resetting, it seems. What if the number is really, really large? 1,000, 10,000, 100,000, 1 million. Still not big enough. But it does seem to make an impact. So let's make this number ridiculously large. And somehow it's still glitching. Okay, let's commit this comment because we want that comment. Let's revisit, I guess, the implementation of how we check if something is running. The number used to be 10. Oh, and Bo is here. Hello, Bo. You're asking if you missed anything. Well, we fixed the waveform display. It is now displaying stuff, but we found out that if your buffer size is too big, then so this is it. This is the waveform display working, okay? But if your buffer size is too big, right now my buffer size is 256. If the buffer size is 2048, then the display just breaks. And we found out that the issue is the reset, the notion of time passing. Oh, so maybe the reset is not the issue, but the sample running is the issue. Yeah, let's isolate this. Let's see if I don't have this condition, if the bug still occurs. I will again increase my block size to 2048. So the bug is happening. Let's reload the plugin with the new code, and the bug doesn't happen anymore. Okay, so the issue is not with the GFX reset. The issue is with sample running. Right now I have a 2 here. What if I have a 10? Does that work? Oh, and there you have it. It does work. Great. What am I missing by making this number larger? It will take a little longer for the GFX block to realize that the sample block is not running. So maybe let's have a 5 here. So yeah, okay. Without having reloaded the plugin, we can see that when I bypass, there is a little bit of a lag. You may not even be able to see this because you're not the person clicking the button, but I clicked just now, and then there is a little bit of a lag before it resets. So I guess what I want is... Oh, you got about half of that. Which half? I can re-explain the other half. In summary, things are going well. We are finding bugs and we are fixing them. But okay, so if I update this number, it will make the detection of bypass a little bit faster, and it seems to be good enough even for this. So maybe the number 2 was too small, 5 is okay. Can we get away with 3? Yeah, it seems like we can get away with 3. So it was just the number 2 was too small. Okay, whatever. Let's double check that my block size is 2048. It is. So, see, it's working now. It was just a 2 that needed to be a 3, because of course, sometimes a 2 needs to be a 3. And if you want to know what this number is and what it does, you can watch the other stream in which I implemented this. It boils down to a fight between the audio thread and the user interface. The audio thread is saying, yes, I am running, by setting this number. Yes, I am running. Yes, I am running. Yes, I am running. And the GFX block is going to fight that by saying, no, I don't think you are, by subtracting 1. No, I don't think you are running. I don't think you're... Are you really running? Are you really running? Are you running? And then every time that the audio thread runs, it reaffirms itself by saying, yes, I am running. Here is a number 3 for you to decrement. And then the GFX block is going to keep challenging by subtracting 1 over and over. So that's how this works. And by making this number bigger, I am making the audio thread say more confidently, yes, I am running. Yes, I am running, because the bigger the number here, the more the user interface thread would need to challenge by subtracting 1 from the number. So yeah, it's a kind of a corollary of this notion of using counters as a way of testing the passing of time. And the passing of time here really is whether a block of code is running or not. All right, okay, we fixed the bug. And let's see what else we have. Okay, we need to investigate the relationship between the buffer size and the smoothness of the waveform. Especially when you're scrolling, and especially when the buffer size is large, this is really choppy. I wonder if it is worth... if it's worth trying to make this smoother. I will claim that it's not. I died on so many hills trying to make this smoother, so I'm just not worried about it. If your buffer size is big, then the user interface thread will be a little bit choppier, but it's fine. It's completely okay. Don't worry about it. But really, I want to look at this at 256 because it's the buffer size that I like using. So this is pretty smooth. And yeah, now we know. Now we know that the buffer size affects the smoothness of the waveform. Buffers make the waveform smoother at bigger buffer sizes. I'll just leave this for the future if someone is interested in tackling that. Maybe me from the future, but I'll leave this for the future. And then rectification. And I guess we can do rectification in the last 10 minutes. So how do we do rectification? Well, it's going to be close to where we do the square root. It's going to be after we do the square root. It's going to be around here. And we do need another argument for this. So it is related to the square root and related to scrolling and erase and whatnot. I guess I will do it here. I'll ask if you wanted to rectify the waveform. And then, yeah, okay, that makes sense. And then I will add another argument or another slider here right after square root. And I will offset everything by 1. And this will be called rectified. And it will be true or false, starting with false, okay. Naturally, I will need to pass this right after square root in the list of arguments, and I will need to check right here if I am on the rectified version. Rectified, question mark. Not rectified. Bunch of things. So if you are not rectified, then that's what you do. And if you are rectified, you will do something similar, but not quite the same. The X position is the same. So maybe we can extract that. Is it worth extracting that? No. Then the top and bottom will change. We will just have, well, the top. We'll just have the top, because the bottom is going to be the bottom of where you're drawing to in rectified waveforms. So we'll just have the top. And what is the top? Well, we want to take the maximum of the absolute values of the minimum and the maximum. Okay, so what we want is the maximum. Now we are doing the rectification right here. We're taking the absolute values of the minimum and the maximum. And that's something that we are going to plug into formulas below. What's the top? Well, I don't want to go to the midpoint. I want to go to the height, and I want to subtract this stuff times the image height. And this is the top. The bottom, that's easy. That's just the height, so I don't need a variable for that. The Y position is the top. And the height, I guess, is this. So I'll do that. And I guess I will call this the Y position. And I think I have everything I need. So I will erase, I will set up the color, and then I will draw a rectangle. From the X position, this is the Y position, and this is the slice height. Okay, let's see if this works. Okay, so far so good. We didn't break anything, and when I want it to be rectified, it is rectified. And if I want to scroll, scrolls just fine. And if I want to take the square root, it doesn't affect anything. Well, it does affect, it makes it taller, but it works. So rectified waveforms, there you have it. We did it. Let's commit what we have and wrap up. Oh, I do want to remove this from the list of things to do. All right. So here is the deal. I will let this be visible. Oh, let's just double check that all our other stuff still works on the rectified version. Particularly the width and height can be troublesome. But it seems like it's all working. Great. Okay, so here is the deal. Tomorrow, I'm gonna take the day off. On Friday, I may be over at IDGQD Sound and we'll be mixing on my You Need to Shower song. Of course, that always depends on availability and everything, so I'm not 100% sure. Make sure that you go to Arya's channel and subscribe to him, and we'll be there. Or if he is unavailable, I will be here on Friday, and we'll continue to work on this waveform. But we are very near the finish line. We need to reintroduce the strokes, and maybe all of this we can just leave for later. And once we have all that, we will start using this bad boy on some plugins. I think I may revisit my auto mixer. We may return to the volume plugin that we have been working on, or that we worked on a couple months ago. I was also thinking maybe doing a gauge or expander. It could be fun. We'll see. But for next time, we are going to finish this that we left off. And yeah, thank you very much, Bo, for being active on the chat. Thank you everyone else who is watching this, maybe in the future. You're all great, and I see you on Friday, either at IDGQD Sound or here. I don't know. We'll see. Thanks for being here. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.